Hello guys, today we're going to study 2.1 Basics of Functions and Their Graphs. So first let's take a look at the definition of a relation. A relation is any set of ordered pairs. The set of all first components of the ordered pair is called the domain of the relation, and the set of all second components is called the range of the relation. All this whole thing they're saying is if we have a set of ordered pairs, let's say we have x sub 1, y sub 1, and then we have x sub 2 and then y sub 2, and more. So we have sets. So we're going to say this x sub 1 and x sub 2, they're the domain. And then here we have those y sub 1 and y sub 2, they're our range. That's all they're saying here. Okay, so let's take a look at example 1. Find the domain and the range of the relation. We have this set 0, 9.1, 10, 6.7, and 20, 10.7, 30, 13.2, and 40, and 21.2. So let's take a look at what is the domain. So this is really straightforward. All our x, right, the order pair x, that is our domain, and all the y is our range. All right, all this. So we can write the solution as the following. Our answer is domains 0, 10, 20, 30, 40, and range is 9, 6.7, 10.7, 13.2, and 21.2. Before we move on, example 2, here we have a definition of a function. A function is a correspondence from a first set called a domain to a second set called a range, such that each element in a domain corresponds to exactly one element in a range. So there's a whole definition, all right? The most important part is right here. Okay, the domain corresponds is exactly one element in a range, right? Exactly one element in the range. That's the most important thing. All right, let's take a look. Example 2, we have determine whether a relation is a function. So let's go ahead draw a graph. Okay, so what I'm going to do is I'm going to draw all my domain on the left side here. So that's my domain where I'm going to write, maybe I'll just write the D right here. So I know 1, 2, 3, 4 on our domain. And here we have range. It's a range I'm going to have 6, right? This is 6 repeated twice. I'm just going to write one time. And we also have 8 and 9. So once I write down the domain and range, I'm just going to go ahead and connect them as a set. All right, 1, 6. We'll go ahead and use the arrow. 1, 6. We also have a 2, 6. Okay, we have a 3, 8 as a set, and 4, 9 as a set. Then I'm looking this relation. Then I'm going to check the definition. The domain corresponds to exactly one element in the range. If we look at this graph, our domain corresponds to exactly one element. Okay, so we say this is a function, okay, because it satisfies our definition. Let's look at our part B. So we're doing the same thing. We'll write down all the domains. So we have 6 repeated twice. So I'm going to have 8 and 9. Range, we have 1, 2, 3, 4. Then go ahead and use the arrow to write 6, 1. We also have 6, 2. Okay, we have 8, 3, and 9, 4. So if I look at this relation, all right, I check again by definition. We need a domain corresponds to exactly one element. In this case, let's look at this. All right, I'm going to highlight it. If let's look at the 6, it's corresponding. We have 1 and 2. That means there are 2 elements in the range. That means this relation is not a function. Okay, because by the definition, it failed the definition. So the easier way to remember is if we have error like this, all right, like the first case we have right here, or just an arrow one time, those are functions. So if we have this split to 2, that means not a function. Okay? On your homework, even though sometimes the question is multiple choice, you must show your work on your tests and quizzes. Otherwise, you won't receive any points. Let's look at example 3. Determine whether a equation represents a function. Okay, let's look at part A. We have x squared plus y equals 4. So when dealing with this type of question, all we have to do is we're going to solve for y. Okay, so I'm treat y as a variable and everything else a constant. I'm going to solve it for y, then I'm going to subtract x squared both sides. Or you can think this as moving this to another side and then change it to the negative. Alright, then y equal to negative x squared and plus 4. Which means for each value of x, we only have one value of y. So we say this, yes, is a function. So let's look at part B. We have x squared plus y squared equal to 4. Again, we're solving for y, so I'm going to move the x squared to another side. That will become x squared equal to negative x squared and plus 4. So once we have this, we're going to take square root of both sides, okay? Then what happens here is don't forget your positive negative. So then this is going to be gone. So we're going to say y equal to positive negative square root of negative x squared plus 4. So from this, we observe there are two values of y. Because here we have a positive negative, that's why we have two values of y. So by the definition, we say this is not a function. Again, on your test, you need to know how to shell work, okay? How you shell work, all you have to do is just solve for y. If y is going to have two values, then that means it's not a function. If y equals only one value, then you're going to say yes, it's a function. Be careful on multiple choices because you still must shell work on multiple choices. Example 4. Evaluate a function. If f of x equal to x squared plus 3x plus 5, evaluate each of the following. So I'm telling my student all the time, if anytime you hear the words evaluating, okay, the words, this is so important. Evaluate, that means you plug in, because you're going to see this type of question a lot in the future. Let me just write it down. Original function, we have f of x equal to x squared plus 3x plus 5. Part A we want to do is find f of 2 equal to something. So again, anytime you evaluate something, you're just going to plug in 2 for every x you see. So which means we have 2. So any x I see, I'm going to replace it with 2. We're just going to plug it in. Which means we're going to have a 2 squared plus 3 times 2 and then plus 5. Okay? Let me just highlight this for you. Any x I see, I'm going to replace with 2. So then the rest is just simplified. It's going to be 4 plus 6 plus 5, which will give you 15. Then let's look at part B. Part B, this time we have dealing with f of x plus 3. The concept is exactly same. This time we're going to say anytime I see an x, okay? Anytime I see an x right here, I'm going to replace with x plus 3. Okay, be careful on this. So again, it's the same thing. Whatever's inside the parenthesis, any x you see, you're going to plug this in. Which means I'm going to see the first x right there. So I'm going to plug it in. That will be, instead of writing x, I'm going to write x plus 3 squared plus 3 times x plus 3. Right? So we see this x again. We're going to replace x plus 3. And then plus 5. I find the students often struggle with this type of question. For example, if this confuses you, let's say if I want you to, put a dollar sign, okay? Dollar sign plus a triangle, okay? And then all you have to do is any x you see, you're going to plug in with dollar sign plus a triangle, and then you have a square, and plus 3 times again, you have a dollar sign plus a triangle, and then plus 5. Again, obviously, this is just an extreme, case to try to explain to you, but the concept exactly same. All right, whatever is your inside your parenthesis, in this case, is dollar sign and triangle, and then you just plug it in to replace with your x. Okay. All right, let's finish part B. So part B, once we plug it in, the rest of the stuff is we're just going to simplify. X plus 3 squared. So I can use this formula. A plus B squared is just equal to A squared plus 2AB plus B squared. Of course, for those of you guys, if you don't like this method, you can always do your FOIL method, okay? It doesn't really matter. So I'm going to write this as x squared plus 6x plus 9. Then I'm going to distribute this. That will be plus 3x plus 9 and plus 5. Once we have this, we're going to collect like terms. We have the like terms here. We also have all the numbers here. So we're going to have x squared plus 9 and 3. They're going to add together, give you 9x. And then we have number 9 plus 5. That will be 18 plus 5. That is 23. So that is your part B. Part C, we have f of negative x. Let me just go ahead and copy this, the original function again, because I have so much student struggle with this type of question, okay? Because I'm not sure, for some reason, just you guys really struggle. So remember, anytime I see an x, that means I have to replace it with a negative x. Because this is inside my parenthesis. Because inside my parenthesis, this is negative x. Any x that I see, I'm going to replace it with negative x. So what I'm going to do is, see an x right here, I'm going to replace it with negative x and square and plus 3 times, again I see x, I replace it with negative x, and then we plus 5. So once we have here, we have negative x squared, it's the same thing as negative 1 squared. Okay, maybe I'll just simplify this. And then x squared. And then it's going to be minus 3x and then plus 5. This whole thing will give us x squared minus 3x plus 5. That's all for 2.11. Thank you and see you next time.